Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of discontinuities. So as per the problem, check for discontinuities in the relation and state the equation of the vertical asymptote. Determine the behavior of the curve on either side of the asymptote. So let's start with the first function. So y equals x squared minus x minus 6 over x minus 3. So this is a rational function. Now a discontinuity in a rational function can be in the form of a vertical asymptote or a hole. So the first step here is to factor this rational function as much as possible. Now the numerator of this rational expression has a simple trinomial. So we can use the sum and product rule to find the factors of the numerator. Now we have to find two numbers whose sum is -1, the coefficient of the x term, and product is -6, the number term. So the two numbers can be -3 and 2. So we can rewrite this rational function as y equals x minus 3 times x plus 2 over x minus 3. So now we can see that there is a common factor in the numerator and the denominator. So we can cancel it out, and that means there is a hole at x equals 3. So we set the common factor equal to 0 and solve for x. So we add 3 to both sides. So we get x equals 3 because the 3 is on the left side get cancelled out. So here we can conclude that there is a hole at x equals 3. Now we can rewrite this function as y equals x plus 2. Now this is a linear function and there is no x in the denominator. So that means there is no vertical asymptote in this rational function. So in this case we can write no vertical asymptote. So we are done with the first function. So now we can analyze the second function. So f at x equals 6 over x plus 3 times x minus 1. Now in this rational function, there is no x in the numerator. So there is no common factor that can be cancelled out from the numerator and the denominator. So there is no hole in this function. In this case, the denominator is already factored. So we can find the vertical asymptotes by setting each factor equal to 0. So the first factor is x plus 3. So we'll set it equal to 0. So now we solve for x by subtracting 3 from both sides. So the 3's on the left side get cancelled out. So we get x equals -3. So this is the first vertical asymptote in this function. Now we can do the same for the other factor in the denominator. So x minus 1 equals 0. And now we can add 1 to both sides. So the ones on the left side get cancelled out. So we are left with x equals 1. So this is the second vertical asymptote in this rational function. Now we can analyze the behavior of the curve on either side of these asymptotes. So let's start with -3. So we'll start with the behavior on the left side of -3. So limit x approaches -3 on the left side. and the function is 6 over, so x plus 3 times x minus 1. Now here we have to analyze whether the function value approaches positive or negative infinity to the left side of negative 3. So we'll have to use a test value from left side of negative 3. So one test value can be negative 3.1. So the test value should be as close as possible to the number at which we are doing the test. So if we sub in x as negative 3.1, so the numerator will always be positive because it's just a positive number. Now in the denominator, so x plus 3 will become negative because if we sub in x as negative 3.1 and then negative 3.1 plus 3 will be a negative value times, and then x minus 1 will also become negative because negative 3.1 minus 1 will give us a negative value. And then, so in the numerator, instead of 6, we can just show that we get a positive value. So in the denominator, negative value times negative value will be a positive value. So the overall value will be positive. Now we can check the behavior on the right side of negative 3. So limit x approaches negative 3 from the right side. So 6 over x plus 3 times x minus 1. So we have to test for a value to the right side of negative 3. So one example can be negative 2.9. Now the numerator will always be positive, and in the denominator, so x plus 3 will become positive because if we sub in x as negative 2.9, the result will be a positive value. And in the second parentheses, so x minus 1, if we sub in x as negative 2.9, we'll get a negative value times. As a result, we'll end up with a overall negative value in the denominator, and that will make the overall value of this limit as negative. Now we can do the test for the other vertical asymptote in this function. So limit x approaches 1 from the left side, so 6 over x plus 3 times x minus 1. So the numerator will always be positive, and in the denominator, if we sub in an x value to the left side of 1 like 0.9, the first parentheses will give us a positive value, and the second parentheses will give us a negative value. So like 0.9 minus 1 will be a negative value, and that will make the denominator a negative value, and the overall result will be a negative. Now we can analyze the behavior on the right side of 1. So 6 over x plus 3 times x minus 1. So we can use a test value to the right side of 1 like 1.1. So the numerator will always be positive, and in the denominator, so x plus 3 will be positive and x minus 1 will also be positive. So this will make the denominator positive, and since the numerator and the denominator are positive, the overall value will also be positive. So now we can write the result, the conclusion from these results. So I'll just write here. So let's start with the vertical asymptote x equals -3. So as x approaches -3 from the left side, y approaches positive infinity because we got a positive value. And then as x approaches -3 from the right side, y approaches negative infinity. And then as x approaches 1 from the left side, y approaches negative infinity. And then as x approaches 1 from the right side, y approaches positive infinity. So this can be the conclusion of our analysis for the second function. Now we can analyze the third function. So this function is also a rational function. There is no whole in this function because there is no factor in the numerator and the denominator that can be cancelled out. So we should start by factoring the denominator. And for this denominator, we can use difference of squares. So we can rewrite this function as x squared over x squared minus 1 squared, which can be rewritten as y equals x squared over x plus 1 times x minus 1. So this rational function has vertical asymptotes, and we can find them by setting the denominator factors equal to 0 one by one. So x plus 1 equals 0, and now we can isolate x, so we subtract 1 from both sides, so the ones on the left side get cancelled out, so we get x equals -1. So this is the first vertical asymptote. And then the second one, so x minus 1 equals 0. Now we add 1 to both sides to isolate x. So the ones on the left side get cancelled out. So we get x equals 1. So this is the second vertical asymptote in this function. Now we can analyze the behavior of the curve on both sides of these two vertical asymptotes. So let's start with the asymptote at x equals -1. So limit x approaches -1 from the left side, it's x squared over x plus 1 times x minus 1. Now in this expression, the numerator will always be positive for both for both positive and negative values. So we get a positive value in the numerator, and in the denominator, so in x plus 1 will be a negative value because the test value on the left side of -1 can be -1.1. So -1.1 plus 1 will be a negative value times. Now for the other parentheses, so -1.1 minus 1 will also be a negative value. So both denominator terms will be negative, so the product will be positive. So we'll get positive over positive, and the overall value will be a positive number. Now we can analyze the behavior on the right side. So x approaches -1 on the right side, so x squared over x plus 1 times x minus 1. So now the numerator will be positive for all x values, positive and negative. Now in the denominator, so we have to use a test value to the right side of -1, so like -0.9. So x plus 1 will be a positive value, x minus 1 will be a negative value. So we'll end up with a negative value in the denominator. So that will make the overall value negative. Now we can analyze the behavior around the other vertical asymptote. So limit x approaches 1 from the left side. So x squared over x plus 1 times x minus 1. So the numerator will be positive. Now the first parenthesis x plus 1 will be positive because test value on the left side of 1 can be 0.9. So it will be positive. And then x minus 1 will be negative because 0.9 minus 1 will give us a negative value. So the overall value will be negative for this limit. Now we can analyze the behavior on the right side of 1. Square over so the numerator will always be positive. Now the first parenthesis x plus 1 will be positive. So for a test value of 1.1, which is to the right side of 1, so this will be positive times and x minus 1 will also be positive. So 1.1 minus 1 will be positive. So the overall value for this limit will be positive. So now we can write the conclusion for these asymptotes. So for the first one, so as x approaches negative 1 from the left side, so the behavior is y approaches positive infinity because we got a positive one. And then the next one, so as x approaches negative 1 from the right side, y approaches negative infinity. Now we can write the conclusion for the other vertical asymptote. So as x approaches 1 from the left side, y approaches negative infinity. And then as x approaches 1 from the right side, y approaches positive infinity. So this is the conclusion for the two vertical asymptotes for the third function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.